When you're not given the altitude of a triangle, this is when you know that you're going to need that formula that I mentioned in the last video. Or even more specifically, when you're given two sides of a triangle and the angle in between. So given two sides and the included angle. When you're given two sides and the included angle, the formula is actually written K equals 1/2 AB sine C. Mathematicians decided to use the letter K because we rarely use it to label the three vertices of a triangle. If we used an uppercase A, most likely there's an angle A in the diagram, so that would throw you off a bit. So they use a K just to make sure that represents area and it won't be confused with anything else. So the way that you're going to do this is really simple. To find the area of triangle ABC, it's K equals 1/2. A is the side that sits opposite angle A, so that's a 6. B is the side that sits opposite angle B, so that's an 8. And then the angle in between them is 30, so you follow that up with sine 30. And then it's really simple. You go into your calculator. You're going to type in 0.5 times 6 times 8 times the sine of 30. And when you hit enter, that's the area of your triangle. And you were able to find that without knowing what the altitude is, or the height. Okay, so let's do another example. Find the area of triangle ABD. So let's draw that. Okay, it doesn't matter where you put your letters as long as the follow-through is correct. AB has a length of 10. AD has a length of 12. And angle DAB, which happens to be the angle in between, is 150. Now notice that it's not drawn to scale. You could draw a much better diagram. I get into the habit sometimes, and it's not always a great habit, of just drawing a triangle that looks like it's equilateral and then filling in the missing pieces, and then hopefully knowing what to do after that. But this is still two sides and the angle in between, so it's area equals 1/2, 10 times 12, and then it's the sine of 150. So if you think about it, the letters that were mentioned in the original formula don't quite match the letters that are in the triangle that we're working with. If you can remember it as two sides and the included angle, you don't have to worry about placement of the letters. So now once again, you're going to go into your calculator and you're going to type in exactly what you see, and we end up with an area of 30. And that's the answer to number 1. Very, very simple. Okay. Number 2, find the area of an equilateral triangle as an exact value, that's importance, if the measure of one side is 4. So now we have an equilateral triangle, so I can just draw that. Every single side is 4. If I was with you right now, I would ask you, in an equilateral triangle, what do we know about the angles? Well, they're all congruent, and if you have 3 angles and they add up to 180, each angle is going to be 60. You can place that 60 wherever you want, but what you need is 2 sides and the angle in between. So we have the 4, and the 60. So K equals 1/2, 4 times 4, and the sine of 60. Now here's the issue. Exact value means that no decimal would be accepted. If you were to put this into your calculator, you would get a decimal. So what we're going to have to do is we're going to have to recall the unit circle, and I'm just going to multiply 4 times 4 to get 16. And if you remember, 60 degrees on the unit circle is 1/2 and rad 3 over 2, and sine is going to be your y coordinate. So now how do you work that out? Well, 1/2 of 16 is 8, and 8 divided by 2 is 4, with a radical 3 that follows along into the final answer. Okay, so once again, 1/2 of 4 times 4, which is 16, that whole thing equals 8. And this is nothing more than 8 over 1 times rad 3 over 2. You can cross cancel. 2 goes into 8 4 times, and the rad 3 is left in the numerator. And that's your answer for number 2. All right, let's continue on down the worksheet and take a look at number 3 and number 4. Number 3, now we're talking about a parallelogram, so let's see how that affects our work. Parallelogram, we know, is a quadrilateral where opposite sides are congruent and parallel. And the area of the parallelogram is 20. Find the measure of the angles of the parallelogram if the measures of two adjacent sides are 8 and 5. So now you're going to eyeball it, and you're going to go with how you drew it. Longer side gets the 8, shorter side gets the 5. If the area of the parallelogram is 20, parallelogram is nothing more than two congruent triangles when you draw a diagonal. So the area of this triangle is going to be 10. So for the first time, we know what the area is. We know what the two sides are, but we don't know the measure of the angle in between those two sides. I'm going to label that with an X, and that's technically what I'm looking for. So now, if you do 5 times 8, you get 40, and half of that is 20. And if you want to get sine of x by itself, you have to divide both sides by 20. So 10 divided by 20 ends up being a half. And now we're forced to recall something that we learned at the beginning of the basic trig chapter. When you want to get x by itself, and the only thing that's preventing that is that sine of x, you have to use second sine on both sides. So you end up with second sine of 1/2, and the sine and the second sine cancel out. Another way to think of this, folks, is when you have the answer and you're missing the angle, you have to work backwards. So you're going to hit second sine, and what happens when you hit second sine, do it real quick in your calculator, you end up with 30 degrees. So what that means for our parallelogram, and I know that I've run into the room for the other problem, I'm sorry, this is 30, opposite angles are congruent, adjacent angles are supplementary. They have to add to 180. So those are the angles of your diagram, 30 and 150. Okay, now I've invaded this space, so I'm just going to draw a line here, and I'm going to do number 4 right in the space that is provided. Finds the area of a triangle when you have A, B, and sine C. This can't be any more straightforward of a problem. Our formula is 1/2 A, which is 6, times B, which is 7, times the sine of C. Now here's the issue. Sine of C is 1/3. You're going to get rid of the sine C and replace it entirely with 1/3. And you're going to see that that's a huge concept in this chapter, something that we're definitely going to discuss more on Tuesday and Wednesday when we see some of the other laws. So now you're doing 1/2 times 6 times 7 times 1/3. Make sure if you're using 1/3 or 1/2, you put parentheses around, and you should get 7 as your final answer. Okay, I know I just did the calculator work off to the side because I didn't want to block the work. But once again, if you're going to use the calculator and you're going to use those fractions, make sure they're in parentheses, and then put this entire expression right into your calculator. All right, so I'm going to end this portion of the lesson or the video right now so that this can stay up on the screen and you can copy down whatever work you've missed, and then the sub is going to start the second half of the worksheet in just a moment.